Imagine having 2 people.
All right. Anyway, I always tell him I'm so disappointed. I want him to be born on Friday. But he's taking 2 days early. He was actually due on St. Patrick's Day. And I was so scared he was going to be born. He was born on Thursday, March 12th, and I was afraid he was going to be born on Friday, March 13th, and I didn't want a Friday the 13th. So he came on the 12th. All right, so here we go. We are getting ready to start a little unit on vectors. What question was on your, what definition was on your test that I warned you about and told you about? Define matrix. The next one is going to have a question that says define vector. A vector is a directed line segment. Write that down at the top of the page. This whole unit is about vectors. Vectors are directed line segments. Okay, these were handed out a long time ago. You have it. It might be stapled to something else. If not, take a picture of somebody's and put it in those. All right, problem number 1A says, find the coordinates of vector AB. That's what this notation means. This means find the coordinates of the vector from A to B. So it's like you're at this point, you want to go to this point, describe that motion. So I'm going to tell you what the answer is, and then I want you to see if you can figure out, how did I get those numbers? Remember, I'm describing how I get from here to here.
Y2 minus Y1, X2 minus, X2 minus X1, and then Y2 minus Y1.
So it's very much like a slope thing. It's how many steps did we take to get from -1 to 3? Isn't that 4 steps? 3 minus -1. And then from 2 to 4 is 2 steps. We don't write it as a fraction. Slope would be a fraction. If I said, what's the slope? You would say 4 minus 2 over 3 minus -1, right? Well, we're not talking about what's the slope, but we're talking about the same idea. What's the movement? The run, rise over run, the run is 4, and the rise is 2. And we always write it as xy. So it looks like a point, but it's really describing how we get from point A to point B. All right, let's see if you can try the second one. The second one says we're going from 2, 4 to -1, 0. So we want to go from 2, 4 to -1, 0. So think about how you're moving. What are you doing in the x direction? -3. What are you doing in the y direction? -4. Those are the coordinates of the vector. That's all there is to it. The vector simply describes the motion. Vectors are movements. All right, what about the next one? What are the coordinates of this vector? Now think about, how are we getting from A to B? -3 to 1 is 4. And -6 to 4 is 10. That's exactly right.
I'm not smart enough.
Pretend you're like a little guy standing at -3 on the number line. And you need to get to 1. So here's where you were starting. Here's where you're ending. How many steps do you have to take? 1, 2, 3, 4. Or, as someone said earlier, it's like slope. 4 minus -6, that's your y. Over 1 minus -3, that is your x. And how about the last one? We're going from 0, 1 to 6, 2. What is my directed distance, or what are my coordinates? 6, 1. Perfect. Everybody got it? That's easy. Now, part 2 says, are these guys equal to each other? Now, in order to answer the question, you're going to have to do exactly what we just did. Find the coordinates for AB. All right, so what are the coordinates for AB?
5, -2.
5, -2. Does everybody see positive 5, -2? Now, do the same thing for CD. So this is still problem 1. Now we have to do CD. So what are the coordinates for CD?
5, -2.
Oh, so the question is, are they equal?
Yes.
And the answer is yes. Yes. All right, let's try B. Same question, are they equal? So Zion, what are we going to do if we want to figure out if these guys are equal? You got to find misdirected distance, Zion. So think about it. Would it be what? I couldn't hear you. It'd be 3, positive 3, and positive 1. That's exactly right. Now do exactly the same thing here, Zion, and see if you get 3, 1. That's what you need to get.
2 and 3.
Okay, well then what's the answer to the question? They are not equal. That would be a no, because their vector coordinates or their directed distances didn't turn out to be the same thing. All right, one more. So this is AB, and this is CD. All right, anybody get coordinates yet for AB? What is it? 6, 4?
Yeah.
Kids, that is the fundamental thing. All the problems are going to be built on this idea. Can you get 6, 4 out of this? All right, what do you get over here?
6, 4.
So the answer to that question is, yes, they are equal. Their coordinates are the same. Part 3 introduces a new vocabulary word. The first thing it says is, find the components that is the same as coordinates. So take these 2 points and tell me what PQ is. These are the components. Don't be confused by the word. These are the components right here, X and Y. So what is it for this guy?
1 or no?
I think that would be positive 1, positive 1.
Yeah.
So that's the same thing, just different letters. That's exactly what we were doing.
It's just the change.
We good here? It's just the change.
The change in Y.
Change it, well, don't write it as a fraction, but it's the change in X and the change in Y, yes. Okay, now, magnitude. Who from physics knows what the word magnitude means? Means length. This is the vector word for length. So when somebody says to you, find the magnitude of the vector, all they're really saying is, how long is it? Now, his coordinates are 1, 1. There are a couple of different ways you can do this. One way it's just common sense. If I start at the origin and go over 1 and up 1, that's what this vector says, go over 1 and up 1. How long would that vector be if I went over 1 and up 1? No, it's not 1. It'd be the square root of 2. Pythagorean theorem, x squared plus y squared equals r squared or whatever, right? So over 1 and up 1. As it turns out, a little shortcut that we'll be using all the time is, when you want to find the magnitude of the vector, you just square its x and square its y, add them up and take the square root. So if I know the magnitude is, or excuse me, if I know the coordinates are 1, 1, the magnitude is always going to be 1 squared plus 1 squared square rooted. The magnitude of this one would be 3 squared plus 1 squared square rooted. The magnitude of this one would be 6 squared plus 4 squared square rooted. To find your magnitude, all you ever need to do, I mean, you can draw pictures, you can do Pythagorean theorem, you can do distance formula, you can do whatever you want. But all you really need to do is square the x, square the y, add them up, and take the square root. That will give you your magnitude. So our magnitude for this problem is root 2. 1 squared plus 1 squared. All right, let's do one more. Letter B. First thing we got to do is find the coordinates of PQ. Okay, so these are our components. We're not going to be confused by that word. We're just finding what is PQ. What would PQ be?
7.
7, 1. Now we want the magnitude,
Square root of 10.
and the magnitude, we use absolute value to note that. Absolute value means magnitude. And that would be the square root of 49 plus 1. How did I get 49 plus 1? 7 squared plus 1 squared. So that's the square root of 50, which of course, like all good math students, will reduce to 5 root 2. Okay? All right, that's it. What happens Friday celebration? Right.
So what do we do? Bring 5, bring 6.
Bring in your treat. Hey, you can bring in your treat before school. That's easier for you.
Do we still do work?
Yes, after we eat.
Can I get it? I'll tell my grandma to make 5. Can we watch like Netflix or something? Can we watch some like a TV show?